The supplement of 58 degrees is found by taking 58 away from 180 degrees, and so that angle is 122 degrees. To find the value of x, we take the 27 degrees away from 90 degrees, which gives us 63 degrees. That's because this here is your right angle, because of the little square in the corner. Y will equal 180 degrees minus 37 because of this straight angle here. So y has to equal 143 degrees. When you have angles at a point, that's 360 degrees all the way around. So the C will equal 360, take away the other two angles of 108 and 114. And when you work that out, that will be 138 degrees. The 89 degrees is equal to x because they are vertically opposite angles. And they are found every time you've got a cross, the angles that are directly opposite each other are always equal. In this next case, we have the corners of the Z shape give us alternate angles. When you have alternate angles in parallel lines, the alternate angle is always equal, so M has to be 110 degrees. Here we have the C shape, so that gives us co-interior angles. Co-interior angles are always supplementary, which means they add up to 180 degrees. So to find the missing angle, we take the 85 away from 180 and we get 95 degrees. The angle F is equal to 70 degrees because you have corresponding angles in the corners of the F shape. So we're going to write corresponding as our reason. Question 15. When you look at the angles here, you actually have also got corresponding angles, but in this case the corresponding angles are not equal. So therefore the line AB is not parallel to CD, and the reason is that the corresponding angles are not equal. The complement of 30 is 60 degrees, so we need to add on to that 60 degrees twice the supplement of 60. The supplement of 60 we find by 180 minus 60, which is 120 degrees. When you work that sum out, you should get 300 degrees. With question 2, you actually have a straight angle along here. So to find the acute angle, we just do 180 minus 115 degrees, and that will give you 25 degrees. Okay, so this angle here is 25 degrees. For the optional challenge that we've got here, we need to use the fact that when you are looking at that diagram, you have angles at a point, and so all the angles all the way around have to add up to 360. So if we write that out as a sum, we've got 8x minus 10 plus the 2x minus 10 plus the 7x plus 10 plus the x plus 10, and that all has to add up to 360 degrees. When you do that, you have altogether there are 18 x's, and when you add, you got minus 10 plus 10 plus 10, that ends up being 0. So I've got 18 x's equals 360. So here, to find the value of x, I just do 360, I divide it by 18, and I get 20 degrees. So because my x is 20 degrees, over here, when I look back at the diagram, I've got 8 times 20 minus 10 putting the x value, replacing the x by the 20. So I'll get 160 minus 10, which is 150 degrees. Same idea here, just again replacing the x. So I've got 2 times the 20, so 2 times 20 is 40, minus 10, that makes that 30 degrees. Here, 7 times 20 plus 10 is 150 degrees. And here, I've got 20 plus 10, which is 30 degrees. So now, in proving straight lines, basically all you have to say is that because this angle here, angle A to B to D, plus the angle A to B to E is 30, plus 150 is 180. So because the adjacent angles add to 180, then that must be a straight line. So that's how you can say DE is a straight line. Okay, since the two angles add up to 180 degrees. You can do the similar proof for the other line, A to C, and that's because in this case you would have this angle here of 150 plus this angle here of 30, and you would show that those two angles add up to 180 degrees as well, making AC a straight line.